Graphs are very important in science because they allow us to represent data in meaningful ways. This video will describe how to plot two sets of data on one graph using Google Spreadsheet. This video assumes we have already produced both experimental data in Tracker and predictions from our computer model in a CSV file. In addition, we assume that we have a Google account to access Google Spreadsheet. First, let's navigate to the CSV file. Once we find it, we will need to upload it to Google Docs. To do so, let's open Google Drive in a browser and find the folder where we want to put our data. Now let's drag the data CSV file into the browser and it will begin to upload. We must now convert the CSV file to a Google Spreadsheet file type. To do so, right-click on the data CSV file and select Open with Google Sheets. This will automatically save a version of the data as a Google Sheet type file. At this point, it would be good to label the data so we don't get it mixed up later. Let's call this column Model Position. Next, we need to get the data from Tracker. Find your Tracker file and open it. Notice the data table in the lower right corner of Tracker. We can highlight the data we want, which, in this example, will be the object's x-coordinate and corresponding time, using, respectively, Control-C and Control-V, or Command-C and Command-V on a Mac. We now copy and paste our data into the Google Spreadsheet. The Google Spreadsheet requires us to organize our data in a certain way to graph it in an informative way. First, let's rename the position data to Experiment Position. We need to combine the time data, both from observations and from the model predictions, into column 3. Let's copy and paste the computational time data beneath the experiment time data in the column 3. Next, we need to copy the predicted x positions into column 5, taking care to match it up with the corresponding time data from the model that we just pasted into column 5. Now we can make a graph. Highlight the 3 combined columns and click the Graph button. We will almost always want to use line charts to represent our data. Click the Charts tab and select Line Chart. If your data looks nonsensical, make sure under the Start tab you have selected Use Row 1 as headers and Use Column C as labels. Click on the Customize tab. We're going to title this graph Model versus Experiment. All charts need axis labels and titles. Scrolling down, we can change the horizontal and vertical axis labels to, respectively, time in seconds and position in meters. Last but not least, let's now change the plot for the experimental data from plotting lines that connect the points to plotting individual points represented by symbols. In this way, if we reserve plotting symbols for observations only and lines without symbols for the model predictions, we can then readily distinguish and compare our observations with our predictions.